Hi everyone, I'm Stephen and welcome once again to Audio Nautica, and this is part 4 of my Marantz 7 preamplifier build. And today I'm going to assemble the actual printed circuit board itself for the preamplifier stage. This may well end up being 2 videos, but definitely in this video I'll get the circuit board itself assembled, and either in this one or the next one we'll test it. So again, as with the other boards in this amplifier, the instructions say to use the bill of materials and the schematic diagram to build the amplifier, and there's a photograph in the manual, and that's about the only reference that you get. So basically you get your bags of parts and your circuit board. I've already pre-bent all of the leads, but just to show you the last one, once again, the way I do this is just with this little plastic jig, and having worked out the correct lead spacing, just bend the leads like so, and that's the easiest, cheapest and way to do it. This thing is worth a couple of dollars and that's about it. So I'm going to dive in now and start fitting these components, and again the rule is to fit them from lowest in height to highest in height. No color codes on these. These are really nice looking Dale resistors. So this one is 909 ohms, so that's R24. Now the fun part, me looking around on the board, but just as I do that, yeah, these are really nice quality component parts that come with it, apart from the 12AX7s themselves look pretty cheap and cheerful, but the rest of them look okay. So there's R24 there, so let's put that one in. Get the leads a little bend like that, they won't go anywhere. It says that all of these resistors are 1/4 watt, but I don't think they are. I think these ones are 1/4 watt. I think these ones are actually 1/2 watt, because they're quite a bit larger in the case size. So I'm just putting these 3 small ones in first. 27K4, R15 and R31. It's up here. This one should be 27K4 as well. And it is R31. Okay. And I'm also just going to pop this Zener diode in because that's the next smallest part, D3, which is down here. Obviously make sure we get that one around the right way. Okay, pop him in. Alright. So they're in now and the leads are bent out, they're not going to go anywhere, so I can just start whacking in some of these other ones. I did sort of pre-sort some of them beforehand, just by value. There's a bunch of 1 megs, there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I've got a pile of 8 of those here. R4 is the first one. R4. R7. There does not appear to be any logic to the way that these are distributed on the board in terms of designator number, which is kind of a bit of a shame. There it is there, R7. R12. Come on, R12, where are you? There you are there. It is good practice, generally speaking, to put these resistors geometrically around the same way, even though they're not a polarized part. R16. R16 is up there. R23. There's that one. R25 is this one here. R28 is this one here. And R32 is this one. Okay, so it'll be good now to get these soldered, because that will mean that I can get these legs out of the way. Okay. Right. And as I've mentioned, I do like to just give them a bit of a reflow. Just a bit of a reflow afterwards. That one's just a bit short on. This is strictly speaking not necessary, but it does give a much nicer joint, because you get this sort of like shear where you've cut off the lead. And theoretically, just the process of snipping it off could stress the joint a little bit. It's very unlikely, but this results in the nicest quality work. Okay. So now it's just going to be a process of going through the rest of this pile of resistors and kind of finding where they go. I haven't really sorted these. Well, I know these three here are all 10K, I believe. $1,003, yep. That should all be 10K. Sorry, 100K. 1003 is, of course. That's why I double check everything, because sometimes the mental arithmetic doesn't quite go to plan. 100K, 3 off, I've got 3 of them, that's good. R2. R2, where are you? Common R2. I'm sure you guys can find it all quicker than me. There we are, R2. R10 and R21. Well, I can see R21 now. I'll whack R21 in, is there? The other one was R10. Where are you, R10? R10, where are you? There we are, right there. Okay, let's see what some of these other ones are. $2,003, so what's that going to be? 200K? Sure is. 200K, there's one of them. And that should be R8. 200K, R8, where are you? Come on, R8. There it is. R8. Okay, this one. 475. Sounds like a big value. . 4751. Not reading all the numbers. So it's 4.75K. There's 2 of those, so there'll be another one kicking around somewhere. So that's R11 or R27. There's R11 there. Okay, what's this one? 3922. 39.2K. Well, that's rather odd. I don't seem to have a 39.2K. I've got a 39K. I'll come back to that one. .681 ohms. 680R, that'll be it. R9 and R26. R26 is up there. Two 493. 249K. I'm just wondering whether they've kind of rounded a few things here, because there's a 250K. There's not a 249K. Come back to that one. 1101. It's 1.1K. Okay, I'm starting to get confused now. Definitely says 1101, but there is a 1K. There is not a 1.1K. I'm just wondering if they've done this just because of what they had available. Well, they've used a bunch of these for something else, like possibly like in the volume control. So this one's 82K. There's no 82K either. There's an 80.6K. $3,652. 36.5K. There's a 36K. $274K. There's a 270K and there's a, yeah, very strange. $8202 is 82K. Again, There's an 80.6K, there's two of them. Well, this is all very odd. $13K. Yes, there is a 13K. Finally, one that actually matches. 1302 is 13K. 13K R17. R17, there it is. $2743. $274K. Yeah, there is a 270K. There's two of them. There's not a 274. 1210. So that's 121 ohms. That's odd. This is getting really confusing, guys. Really, really confusing. Close values, but values that don't actually match what the schematics say. $4.75K. Yes, R11 and R27. There is R27 there. $1303. 130K. There is 130K. That's R3. R3 is that one. Two to go, guys, and I've just sort out what's going on with these other ones. 1101. 1K1. Yeah, that's weird. There's like 1K. I can't see 1K01. And this one. $680 ohms. R9 and R26. R9 is that one there. Okay. Oh dear. I've got a solar splash right in the hole. That's annoying. Just working out how to do this without getting a burnt finger. Alright, we'll have to do it like this. Okay, that's got it. Alright, let's get these all soldered in anyway, and then I shall need to work out what's going on with these other resistors. Once again, just give these a bit of a reflow. Alright, it's not looking too bad. Okay guys, I'm just going to sort these resistors out just to work out what's going on, and once I've done that I will come back. Okay guys, so I have sorted these resistors. I'm happy enough with the values, so I'm going to whack these in. 1101, 1.1K. So that should be R13 and R29, I believe. Actually, it's 1K according to the schematic, but R29. R29. R18, where are you? R13, that one there. It's rather confusing because I found an error on the schematic. It's got two R18s, one of them's actually supposed to be R1. So that threw me a little bit. 1210, so this is 1210, that's 121 ohms, which is really close to 100 ohms. So I think this is supposed to be R22. There you are there, R22. I think this is actually the resistor divider for the regulator for the heater voltages, so this may change the heater volts slightly, but we'll see when we power it all up. 2493, so that's 249k, which is probably meant to be R6, which is 250k. R6, where are you? There you are. I think this light's helping, so let's get rid of that light. Okay, I've got two of these guys. 2743. So that's 27k. So no, it's not. It's 270k. It should be R1 and R20. R1, there they are up there. R20. Three, 6, 5, 2, 36k. R18. There we are, R18. Three, 9, 2, 2. 39.2k. There is a 39k, which is R5. There it is there. How they can really expect someone to build this thing, I'll have no idea unless you've got a pretty good idea about electronics. You can just be completely thrown that these values are not what's on the schematics. 8202, 8202, it's 82k. Well, theoretically, it should be the last two. Yeah, that'll be right. I can see 4 holes already. R14 and R30. R19 and R33. Anyway, R19 and R33 are meant to be 80.6K. These are 82K. Interestingly, on the schematic it says that there are 82K. 19 and R33. So, that one in. R33. Right. Okay, so there, I've checked on the schematics, there is no, or the bomb at least, there's no R14 or R30 on the bombs, so I'm happy enough with those not being fitted. So let's just get the last of these resistors soldered in. Right here. Ouch, my finger was on the other side of that one. Okay. Right, I think that's all of the resistors fitted. So we'll work out what to fit next and we'll move on from there. So moving on with our components in order of height, I've got these lovely Mkp capacitors. So 6 of those to fit, C1, C2, C3, C7, C8, and C11. Once again, just give these a bit of a reflow. They've created this multi-pad footprint, which basically means you can put any capacitor in there of any lead spacing, but it makes it more difficult to solder because the extra pads tend to just take the solder. Certainly doing something like that in a production environment is really bad news because it makes it much more difficult to get controllability or repeatability on the solder joints. Solder tends to go into places it's not meant to. It's especially bad with surface mount components, which we don't have any here. But yeah, it's a real trick to think that you're making life easy for yourself by creating a multi-pad footprint, but it's a nightmare in production. So we're going to put these connectors in now, and you can see here we have the problem with the height is because we've got tall components down this end here, and these ones are shallow. Well, it wants to fall down on the shallow side. So what I'm actually going to do is I'm just going to prop it up by putting that guy in there for now. There we go. So now it's the same height. Just tack these in there for now. to make sure that they're properly seated. So add this guy in while we're at it. Now the last one goes here, but you can see there's going to be a thumping great big capacitor. It's this one actually, will go there. So if I put the connector around this way, I won't be able to get the wires in because this will be in the way. So therefore we need to put this around this way. There's nothing on the footprint to really indicate which way it should go, but we're going to put it that way. Again, make sure it's properly seated, and it wasn't. It went up 1/2 mil closer to the board just as I reflowed it, pushing it from the bottom. So I'm having the same issue that I had on the last board, the input selector, and that these just really don't seem to want to solder. Whether the legs are a bit tarnished or something. So just a little bit of this liquid flux I think will help to solve that problem, hopefully. Okay, so I'm going to put in the next tallest component, and that's these valve bases. They're lovely looking ceramic, as you can see, with gold pins. They look like they're decent quality, which is good. No plastic rubbish. So get the legs to line up. So the reason why we need to do this in height order is, yeah, look at that. See, it just falls out as soon as I turn over the board. So once again, we'll just need to do our trick of tacking it in and then making sure that it's properly seated with the board. Okay, feels like it is. Oh no. One of the legs is missed. Well, that's a problem. This leg obviously missed, which is kind of bad. So I'll need to wick this out and try again. Gotcha. Now, you could argue that I should perhaps be editing that out, but part of the whole reason for this is to learn together. So if I just edit all of my mistakes out, then you guys won't learn anything. So what I should have done is check that all the holes, all the legs were actually in the holes first, and this time they are. So as you can see, that one was easily resolved. So now once again, and this time I was too impatient. I didn't wait for the joint to actually go solid before I took the before I lifted the board up. So I lifted the board up, and the part stayed there. And now it wants to be difficult. Right. Third time lucky, perhaps? Let's hope so. Okay, in. Check that all the legs are there. Check. Solder it. And this time, wait for the joint to go solid. And now we make sure that it's, yep, seated properly. And I think a bit of liquid flux would probably do good on these as well. This Thermaltronics iron that I'm using, the wand or the base has got a little switch in it, so basically the iron turns itself on when you take it out of the stand, which means that the downside of that is that I have to wait for the tip to heat up every time I do that. I don't really like these sort of like convex joints, even though it's probably not a problem ideally. Sorry, concave joints, they should be convex. But because they're such great big holes, we'll see what it looks like on the other side. Too much solder, it'll all go running down. Yeah, that looks okay. But I don't want huge amounts of solder out this side, which is what would happen if I just kept on pouring solder into those joints. So, we do the next one now. Make sure that all the legs are through. They are. Okay. Make sure that it's seated properly. It is. And away we go. Okay. Lucky last. So you can see, again, because the other end of the board is lower, it just wants to rock up. So what that means is that it will, well, I can do it like that, push it down as I solder it. And that'll resolve the problem, but still need to check anyway that it is seated properly like so. There we go. You can see that it's still rocking around, probably because the pins are free relative to the body, so I'm just going to hold it down as I solder these ones here, and it should be okay. Okay. There we are. Let's have a quick look at these under magnification. This one's got like a void or something in it. That's better. Okay. Beautiful valve bases. Right, so most of the rest of the components are starting to get quite tall now, so I'm just going to... These ones are the next ones. This 2.2 microfarad Mkps, made in France, gorgeous looking. So that should be C14 and C15, that's these ones here. Bit of liquid flux just to help these guys. Starting to come on. Right, who shall we do next? I've got these Weimer MKPs. And I've got these little, I might put this guy in next. What's this? 100 mic, 50 volt. I believe that should be C19. Yep, C19. What's this guy down here? Get the polarity around the right way. So just the nature of this part, again, is very unlikely to actually sit, yeah, felt that come up a good millimetre. That's much better. close that guy. Okay, I think we'll do these Weimers now. So these are 0.1, 400 volt. Should be 5 of them. 1, 2, 3, 4, 5. So it should be C4 and C5. C4. C4, C5, where are you there? C5. C6, this one. C9, this one. And C10, that one. Oops. Okay, so you can probably see how these are all rocking around on the board, so these will certainly need to be tacked and then straightened. I'm sure you can hear that. Oh yeah, that one was way out. Sure you can hear that click as they all thump into the board. Okay, starting to come along quite nicely. So yeah, I think we'll get this guy out of the way now. What's this? This is audio, Nichicon 220 mic 50 volt. 220 mic 50 volt should be C18. Okay, that's it there. C18. Footprints for a much larger part, but C18, 220 mic 50 volt. Definitely correct. Looking good. Right. So there's not that many itty bitty parts left. Got these guys here, which Q2, how does this work? Anyway, this must be Q2, Q3, Q5 and Q4. Should be these guys down here. Q2, Q3, Q4 and Q5. Q2, Q3, Q4, Q5. Says they're all the same. It says they're 2M3440s. What are these? 2M3440. Okay, yep, they are all what they say they should be. Okay, this way. Helps if you put it in the right way around, generally speaking. So basically, these transistors look like they are for the HT regulated supply. They are supposed to work with a pass transistor, an MJE13005, to make a regulated 240 volts DC. So I'm really hoping that when I plug this in, that is what it will actually do. Although I'm really not quite sure why it actually needs a regulated DC voltage. I guess probably because you don't want it to change under load. Right. Yeah, that looks pretty good. Woohoo! Coming along nicely. Right, I think I'll whack these guys in now. KBU 1010s. See how tarnished those legs look? So I really don't like the look of those legs. I'm going to give these a bit of a clean before I solder these in. And I'll be right back once I've done that. Okay, so now we'll whack these bridge rectifiers in. Come on. There we go. This one. That one was not flush. That's why we do that. It's not straight either, which is a little bit harder to tell. Okay. So you can certainly see with these great big legs how trimming the legs off the joint kind of mangles the joint somewhat. So just by reflowing this, we'll end up with a much nicer joint than we have now. They look much better. Right, that's those ones. So, there's not many parts left now. So the question is what should we do now? How about C16 and C17, which is bound to be these guys here. 2200 mic, 50 volt. 105 degree rated parts. It's quite nice. So they should be C16 and C17. They are. And these are the input capacitors to the regulator for the heaters. Okay, so plus is down the bottom. So do these one at a time, I think. Yeah, see how terrible that is. Oops, I forgot to make sure it was flush first. It's alright, we can do so like this. But I think it's pretty, oh no, not quite. It's pretty close, but yeah, that looks nice. Right. So, believe it or not, guys, we've actually only got 4 components left. We've got these 2 great big electrolytic capacitors. BC Fichet and a Rubicon. So C12 is probably going to be this one here. C12 is 330 mic, 450 volt. Oh, no. Oh, that must be this one. C13, 100 mic, 400 volt. 100 mic, 450 volt. Close enough. Okay, that's this one here. All right. So, let's just have a look. Now, what did I say this one was? C13. I just want to find that on the schematic. There it is, C13. Yeah, okay, so that's the output. Right, C13 is the output of the regulated HT. C12, which is this one, is the input of the regulated HT. They are both connected to ground. There's no polarity marks on the board, but this should be ground, and that should be ground. And there's a point here somewhere. There it is over there. There's a point here marked ground. Yep. So that's where the negative lead is going to have to go. So C13 is 100 mic, negative to there. Okay, and then this guy, negative is that one there, which means it goes around this way. Right. So that is everything except for these two guys here. These are the regulators. So one of them should be an LT1085. That's that one, LT or LM1085, same difference. And this one is supposed to be an MJE 13005A. Okay, yep. So this is actually a NPN transistor, which is a series pass transistor for a HT voltage, making 240 volts DC. This one here is an adjustable linear regulator, which just has a resistor divider on pin 3, which is set to make 12.6 volts more or less. So we have one heat sink, which is going to go there. And once again, they have provided sill pads and they've provided nuts and bolts and things, and this insulating sleeve to electrically insulate it from the heatsink. So this is going to be kind of fiddly, guys. So I don't think you're going to be able to see very much because my hands will be in the way. So I will assemble this off camera, and as soon as I've done that, I'll come right back. Okay guys, so as you can see, I've got this component fitted here. This is the MJE13005. It's the pass transistor for the HT. I'm not especially keen on this heat sinking arrangement because the heatsink, basically there's a couple of locating lugs here that located in the board, but there's nothing actually holding it onto the board except for the actual component legs themselves. So basically, if you have any force applied on this heatsink, it's the component legs themselves are going to take that force. So I'm not especially keen on that, but that is how it's designed. Feels solid enough that a big good whack would probably destroy the component. On the other hand, however, as you can see, I have not fitted yet this LM1085, and that is because we have run into a bit of a showstopper here. This heatsink that has been supplied, there's two holes here which an M3 screw is supposed to go into, and then you can see that here's the holes here and the component goes there. Well, there's one slight problem. So if you look at this, you can see that the holes do not line up. So they are closer together than they are supposed to be. So I cannot mount this heatsink on this board, which means kind of, I'm stopped until I can come up with a resolution for this. So I'm going to have to go away, and I can't drill new holes. It isn't going to work because you can see that they're too close. If I tried to drill holes in the right place, I'd just end up with basically a slot, and that wouldn't work. So I think plan A is I'm going to have to try to find a heatsink, hope that there's a heatsink. Hopefully they haven't stuffed up. Hopefully they've just supplied the wrong heatsink. So anyway, I'm going to have to do some investigation. Hopefully I can find a part that I can make work with these holes, or else one that'll have some holes down here, because I can't drill holes that will work with this heatsink. It just isn't going to work. So off I go, and hopefully when I come back I will have solved that problem. Okay guys, it's kind of been one step forward, two steps back with this thing, but I think we're finally getting there. So it's become pretty apparent to me that this board has been designed for a different heatsink to the one that was provided. So I checked their website. It does look like this is the one that they have on their website, and it looks like this is the one that's in the photograph as well, but it certainly doesn't match the footprint. So it also became pretty clear to me that I was not going to be able to easily find what is supposed to be there. So as you can see, I have made this fit. So I did have to go in the end with some slots, which actually don't look too bad because I had to put these washers in to deal with the extra hole size, but that means that you can't see the slots, and so this is firm. But also the board kind of like hangs out further on from the edge of the board. The heatsink hangs out further from the edge of the board than it's supposed to. So I've had to do this fancy leg bending arrangement to get the regulator in, but the regulator is in. Now, the problem that I had, however, is because the heatsink was hanging over the edge of the board further than it's supposed to be, it meant that when I put the board in, it actually fouled against the input selector. So I had to move the input selector board over this way, which was a kind of a real pain to get that done. It means that this connector here is really close to this side panel. So I've pre-fitted these leads here, which will be the input through the volume pot, which I've not fitted yet, into the input side of the preamp board. So, and while I was at that, I've done a little bit more harnessing. So I've done this harness here, which is the output harness, and this harness here will be the output of the preamp board itself. So these two will go here, so they go through the delay board and then out to these output RCAs. So that's a step forward, at least while I was mucking about with this mechanical stuff. So basically all that I need to do now to this preamp board is I've just got to actually solder in the regulator, because I haven't done that. So I'm going to solder that in now. And of course it's not a regulator, it's actually a pass transistor. Give them a bit of a reflow as I do. Okay, so everything is now fitted to this preamp board, so we just need to give it a clean. It's actually really sticky around, especially around here. Really sticky just with all of the flux. So as I mentioned before in a previous video, it is really good practice to get this stuff off. Okay, so this board is cleaned up, and one of the reasons to clean it up too is, of course, it makes it much easier to inspect the joints. And doing so, I can see that there's, mainly on these valve sockets, there's a few voids. So just here, there's a void in this one, and you can see the difference. Say, for example, between this joint here and say this one here. Not enough solder. So I'm going to add some more solder into these, but apart from that, it looks pretty good. So I'll just fix those few joints up off camera, but this board is now hopefully more or less ready to go. I'm going to wrap this video up here because I'm mindful this has been a fairly long video already. So I'll do the testing of this board on the next video, and hopefully more or less most of the testing on the amplifier. So please do watch out for that video. Thank you so much for watching. Please subscribe to my channel. It makes a huge difference to me. If you hit that subscribe button, give me a like, and also you can support my work on Patreon, and I'm on Instagram as well if you want to reach out to me. So thank you so much for watching, and I look forward to seeing you on the next video and in the next part of this series of videos on this Marantz 7 clone preamplifier. Bye for now.